Today we are going to discuss a very important problem related to the random walk. Actually, in this lecture, our aim is to find the probability of one dimensional random walk, not walk, but you should say random walk. Okay, so we will actually calculate what will be the probability of one dimensional random walk. In the previous lecture, we have actually only discussed the Einstein theory of Brownian motion on the basis of the problem of random walk. But this problem is actually to find the probability of one dimensional random walk. When you say random walk, that means a motion which is completely haphazard, which may take place in any direction. Okay, but here there is one restriction because we are considering only the problem of one dimensional random walk. So actually in this lecture we are not going to find the probability of random walk in case of any type of motion, but that motion of random walk must be restricted, must be constrained along a straight line. So I have considered here this is just a straight path, and you can take this just as an x-axis, and this point O you may take as an origin from where the motion of a particle or a body or any person may be started. Okay. When you say a random walk, that means aimless motion. There is no particular aim of the motion. So you can take a very good example for the motion of random walk as motion of a drunk person. You know, when a person actually drinks, his mind is not in his command, and if the person moves, the person can move in any direction. So the motion of or walk of a drunk person is a very good example of a random walk. But according to our problem, we have to restrict the motion of that drunk person along a straight line. So I have considered here that this is the motion of or the walk of the drunk person starts from this point O, which has been taken as an origin, and the person moves along this x-axis. Okay. But you know that the probability of this one-dimensional random walk will depend on the specific rules governing the movement. For example, here we consider that the drunk person starts at the fixed position O and moves either to the left or to the right with equal probability at each step. Actually, this is our restriction. This is the constraint which has been imposed on the motion on the random walk of the person. Okay. So we will discuss this problem under this constraint that the particle you consider which is in random walk or the person which is in random walk moves either to the left or to the right with equal probability at each step. This is our restriction. Okay. So now let us consider that the particle or the person takes n steps. N is the total number of steps, and each step is of equal length, and that is equal to L. This is also a very specific condition. Okay. And we consider that in each step the particle or the person moves to the left with a probability p, okay, and at the same time the probability of moving to the right is, let us say, q, okay. In fact, in that condition you can say that this probability p and q will be equal to 1 by 2, because the person will move either right or left, okay. So the number of events will be 1, but that may be 2, so you know that probability will be equal to 1 by 2. So this problem is restricted when we consider that p and q are equal and both are equal to 1 by 2, okay. Now let us consider that this p of mn, this symbol actually represents the probability that the person is at a point m steps away after n steps. It means what are you saying? Let us say that after n step the person is at this position, let us say A, okay. Here the person is after n steps, and after this n step he makes m steps, okay, and then he or she is at this position. Or you can say that after n step the person may be in left side at this position B, and after that he takes m steps, and then he is at this position, okay. So this p of mn represents the probability that he is at a point m steps away after n steps. Mark this, okay. So in this condition you can easily say, according to the theory of probability, that the probability of any given sequence of n steps will be equal to what? That will be actually equal to 1 divided by 2 to the power n, 2 to the power n, and you can also say that this is 1 over 2 to the power n, okay. Now if we consider that this w of m, this is not a function of n, this is also actually a function but only of m, and this w of m actually represents the number of distinct sequences that reach m after n steps, okay. So in that condition, if you want to define the value of this p of mn, what will be that? We must divide the value of this w of m, which represents the number of distinct sequences that reach to m after n steps. We must divide this w of m by 2 to the power n, 2 to the power n, to get the probability that the particle or the person is at a point m steps away after n steps. So equivalently you can write that this p of mn is equal to this much. This is w of m divided by 2 to the power n, okay. And I have written it like this: 1 by 2 to the power n times wm, okay. Now to find this probability p, let us consider that to arrive at point m, some set of n1 equal to 1 by 2n plus m steps out of n step must be positive, okay. And similarly out of n steps, this n2 equal to 1 by 2 n minus m steps must be negative, okay. Actually when the step will be in towards the right direction from this starting point O, then we have to take the step positive, and in left direction we must take it negative, okay. So we consider this particular sequence, okay. So in this condition, what will be the value of this w of m? In accordance with theory of probability, that the number of distinct sequences that reach m will be what? That will be W of m equal to n factorial divided by 1 by 2 n plus m factorial times 1 by 2 n minus m factorial. Okay. So this is the value of W of m. So once you get the value of W of m, then you can easily find the what will be the value of this P of mn. You have only to divide this W of m by 2 to the power n. So you can say that this P of mn, what will be this? This will be W of m and divided by 2 to the power n. Okay. Actually, to find the value of P of mn, as you know that n will be very large, so this as n is very large in this condition, to simplify the result, we must take under account the Stirling approximation, because you know that whenever the number n is very large and we are dealing with the problem involving n factorial, then the calculation is very tedious, and when we will take the logarithmic value and apply the Stirling approximation or Stirling formula, then the calculation becomes very easy. So definitely you have first of all to find the logarithmic value of this P of mn, and then we will apply the Stirling approximation to find the our final aim is to find P of mn. But for getting that, as that expression will contain the factorial of a very large number, so to simplify that result we must take under account the Stirling approximation, and for Stirling approximation we must have the logarithmic value of the factorial of these large numbers. So you can see that in the expression of W of m there is n factorial, there is half n plus m factorial and half n minus m factorial, and all these numbers n, m plus m, n minus m will be very large. Okay. So we must take the logarithmic value of P of mn. I have not substituted here the value of W of m again. You can see that this is your value of W of m, and so when you will take the logarithm or the natural log of this log P of mn, what will be that? You can see this will be log n factorial minus log 1 by 2 n plus m factorial minus log half n minus m factorial and minus n log 2, because when you will take the log of this log 2 to the power n, that will be n log 2. Okay. This is just a simple property of log, that log a by b is equal to log a minus log b. Okay. And when you take the logarithm, this product becomes the product is converted into sum, because log a into b is equal to log a plus log b. Okay. Now you know that according to a Stirling approximation, if x is a very large number, then log x factorial is equal to x log x minus x. Okay. This is although a special case, not a general expression for the Stirling approximation. We will finally use the general expression for it. But for simplicity, I have assumed here first of all the simple and the very special result or a special case of this Stirling approximation, which reads like log x factorial equal to x log x minus x. So on the basis of this formula, you can write the expression for log n factorial, for log half n plus m factorial, for log half n minus m factorial on the basis of this result. So you can see, instead of this log n factorial, you can write n log n minus n. You can write, okay? And for this log half n plus m factorial, okay? Here at the place of x there is 1 by 2 n plus m. So this will be actually minus n plus m by 2 log n plus m by 2 and minus n plus m by 2. But since here is minus sign, so this minus minus will become plus. So this term is plus n plus m by 2. Okay, and for log half n minus m factorial, we will write minus n minus m by 2 log n minus m by 2 and plus n minus m by 2. Okay, and this term n log 2 is at each, you can see. Now see that when this you can see here that in this term, which is I am just underlining, you can see there is two terms n by 2 plus m by 2. Okay, m by 2. And in the last term, in this term, you can see there is plus n by 2 and minus m by 2. Okay, and in the second term there is minus n. So you can see this n by 2 and n by 2 will be plus n and this minus n cancel out, and this m by 2 and this minus m by 2 will also cancel out. So this term n and n plus m by 2, n minus m by 2, all these will cancel out. So what are the remaining terms? The remaining terms are n log n, see here, and minus n plus m by 2 log n plus m by 2 and minus n minus m by 2 log n minus m by 2. Okay, these are the remaining terms. So you can see I have written it here that log p m of n, this is equal to what? The remaining terms which you have seen there, you should write down those terms here. Okay, so let us see. This is n plus m by 2 times log n plus m by 2 and minus n minus m by 2 times log n minus m by 2 and minus n log 2. Okay, now we will again find the approximate value of this these terms log n plus m by 2 and log n minus m by 2. Okay, now you know that this log 1 plus minus x, log 1 plus minus x, this is almost equal to plus minus x square by 2, but only when x is very small. When x is very small, we actually neglect the higher order terms, and so log 1 plus x is x minus x square by 2, and this 1 minus x is actually equal, sorry, here there will be actually, yes, and when there is log 1 minus x, then this will be minus x square by 2. Okay, so on the basis of this result, you can simplify this log n plus minus m by 2. Actually, in our expression there is both terms containing n plus m by 2 and n minus m by 2. So I have written it here in fact in one equation, that log n plus m by plus minus m by 2. What will be this? Actually, if you will take this n by 2 as a common factor, this result will be log n by 2 times 1 plus minus m by n. Okay, now this can be written as log n by 2 plus log 1 plus minus m by n. Okay, now this log 1 plus m plus minus m by n, this can be simplified on the basis of this formula, on the basis of the expansion of log 1 plus minus x when x is very small. So assuming that this n is very large, n is very large. When n will be very large, then this m minus n will be much smaller than 1. Okay? And in that condition, you can write this log 1 plus minus m by n equal to plus minus m by n and minus 1 by 2 times m by n whole square. Okay? On the basis of this formula, you can see it here. So log n plus minus m by 2 can be approximated as log n by 2 plus minus m by n minus half m by n whole square. So at the place of this log n plus m by 2, now you have to write log n by 2 plus m by n minus half m by n whole square. You have to write. Okay? And at the place of this log n minus m by 2, you have to write log n by 2 minus m by n and minus half m by n whole square. Actually, substituting these values in this equation, which I am marking here, when you will put these values and simplify, then you will get a very simple result. Actually, I have not substituted this value here and not simplified the result, but this is just a homework for you because that will be just some extra steps, you can do it. So I have written the result directly. But I am suggesting you must put the values of this log n plus m by 2 and log n minus m by 2 on the basis of this result which I have obtained here. And then after doing the algebra, doing the simplification, you will get a very simple result that log p of mn is equal to m square over 2n. This simple expression will be for log p of mn. Okay? And so as log p is equal to m square by 2n, so this p will be equal to e to the power minus m square by 2n. So you can see that I have actually found this probability p. Okay? But this value of p has been obtained when you have considered the Stirling approximation like this, that this is log x factorial equal to x log x minus x. But you know that the general expression for log x factorial or the general Stirling approximation when n is very large is like this. Actually, when n is very large or x is very large, you can say that in that condition the Stirling approximation in most accurate form, in the correct form, is given like this. This is log x factorial equal to x log x minus x. Okay? And plus half log 2 pi x. Actually, in the previous expression, we have not written like this term 1 by 2 log 2 pi x. But this, when you will add this 1 by 2 log 2 pi x, this will be the most correct version of Stirling formula. Okay? Actually, when this expression or this form of Stirling approximation will be used, then as you can see, the multiplicative factor of this exponential factor e to the power minus m square by 2n is here 1. This is 1 times this much. But this multiplicative factor 1 will change when you will take this most accurate version of Stirling formula. In fact, I have not done that algebra. You should remember it. When you will use this formula as a Stirling approximation, then we get that the multiplicative factor of this exponential factor is not 1, but this is 2 divided by root over 2 pi n. You will get. Okay. So the most accurate expression for this probability P of Mn will be what? This is 2 divided by root 2 pi n times e to the power m square by 2n. Okay. And this was our aim to find this probability. Okay. But now we will express this probability something in terms of the value of L, which actually is the value of each step of the particle or the drunk person. Okay. Now, as you have seen that since in each step the drunk person cover a distance of L, so when he or she will make m steps, what distance he or she will cover? You can easily say. In fact, in one step distance covered is L, in second step also L, in third step also L. So in mth step the distance covered will be also L. So you have to add this L m times. So you can say that after m step from the origin, the person is at a distance x, which is equal to ml. Okay. Although I have shown here that the steps is in one direction, but as you know that this step may be either in right direction or in left direction. Both in both direction the person actually move. Okay. So actually when we will take that the what will be the value of delta m, that you have to take 2, because this has integral value in both directions. Okay. And so in that condition, when we take if a small change in x, that is dx, that will be not equal to L into dm, but that will be equal to 2L into dm, because you can see I have actually mentioned it here that in this condition dx will be 2L dm, as m can take integral values separated by delta m equal to 2. Okay. Now again you can see that I have considered that this n1 is equal to 1 by 2 n plus m. Okay. And you have considered that n2 is equal to 1 by 2 n minus m. Okay. N minus m. So when you will find the value of n1 minus n2, you can see when you will subtract this n2 from n1, what you will get? You can easily see that we will simply get m. So this m can be written as n1 minus n2. Again, when you will actually add these two, that is, if you will find n1 plus n2, you can see that m by 2 in two terms will cancel out and the result will be n. So n1 plus n2 is equal to n, and therefore what will be n1 plus n2, and this is n2. So you can see from here that this n2 is equal to n minus n1. So in fact here at the place of n2 I have written n minus n1. Okay. And so this is equal to 2n minus n. Okay. Now if your aim is to find the probability that the person is between x and x plus dx after n steps, what will be that probability and how that will be represented? Actually we will represent that probability like P of xn dx. And you know that after this distance, in covering this distance x, the person has to make m steps. So instead of this x, you can change the parameter to m, and instead of dx, you may write dm. So this probability can also be represented like p of mn dm. But as I have told you just now that this dx is equal to 2l dm. So this dm will be equal to dx divided by 12. So instead of this dm, I have written dx by 12. Now you can see that this dx and this dx will cancel out, and so this p of xn, that will be equal to what? That is p of mn, see here, and divided by 12. So this is 1 by 12 times p of mn. Okay. But we have just obtained the value of p of mn. You have seen that the value of p of mn is 2 divided by root over 2 pi n times e to the power m square by 2n, m square. But what will be m square? You can see here. Actually, see here, this is m square by 2n, and as x is equal to ml, so this m will be equal to x by l. So instead of m square, I have written here x square by l square. Okay. Now this 2 and this 2 will cancel out. Okay. And so you can write this multiplicative factor as 2 pi l square times n to the power minus half, because I have taken these numbers in denominator, in numerator. So power has been minus. Power becomes minus half. Okay. And the second factor, exponential factor, remains at each. So this is the value of the probability that the drunk person will be at a distance x from the starting point O, okay, after making n steps. This is the probability, and this is the probability of one-dimensional random walk. Okay. Now you can see that if you will plot this p of xn in against of x, as you can see that with increase in x either in positive direction, this is your positive direction, or in negative direction, this p of xn will decrease, because the power on exponential is negative, and as there is x square, so the value of p will decrease in both directions with the increase in x either in positive direction or negative direction, because x square is even. So when you will take, let us say, x equal to plus minus 1, x equal to plus minus 2, the value will be same, because after squaring minus will become plus. So you can see that this probability will be maximum when x is 0. So at this origin, the value of this p of xn is highest. This is the value of maximum probability. Okay. And as one moves from the origin either toward the right direction or the left direction, the probability decreases symmetrically. So this is a curve lying in the second and the first quadrant. Okay. And symmetric about this pxn axis. Okay. This is just like a parabola, you can say, or this is just the graphical plot of normal distribution. This is the graphical plot of, in statistics you study normal distribution. So this probability distribution is just like a normal distribution, and you can see from this result, if our aim is to find the probability for a given particular step, then you have only to substitute that value of n here. For example, you can take n equal to 20, and after taking n equal to 20, what will be the probability for a given value of x, that can be easily found. Okay. So this is all about the problem of uh, finding the probability of one-dimensional random walk. I think you have understand each and every step clearly. Something I have not done in this lecture, some simplification, and I have told you that that is homework for you. So watch the video seriously, and where there is needed, do the needful algebra. You will get the result. Okay. So thank you very much.